Okay, this discussion is properties of water. Now, if you remember from our PowerPoint a couple times ago, water is our example when we talk about covalent bonding, that this hydrogen atom and this hydrogen atom each have one electron. How do we know that? Because if we look at the hydrogen in the periodic table, it has one proton and one electron. Here's its proton, here's its electron. Okay? Oxygen, its atomic number in the periodic table is 8. That means it has 8 protons in its nucleus. And 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outermost energy level. 8 electrons. Okay, because of this sharing of electrons, because of the way they share electrons, and we don't need to get into this for this class, water has would have the 2 hydrogens on one end and the oxygen on the other end. So it kind of looks like, you flip it around, it looks a little bit like Mickey Mouse. The hydrogen's here, the oxygen down here. Okay, we're going to come back to why that is, or what happens with that in a minute. Skip this slide. All right. So what we want to do today is talk about water is what we're mostly made of, 67% or 60% water, and water is in pretty much everything alive. And so what makes water so important? In fact, when we go looking for life on other planets, one of the first things we as humans look for is the existence of water. So what makes water so important? Well, let's look at some properties. Here's one property of water. This would be property number 1. That the solid state is less dense than the liquid state. This is one of the only kinds of matter on Earth that this is true for. It's a very unusual property. So the result is that ice floats, which makes it very important for things that live in the water. Not necessarily that important for you and I, because we don't live in the water. But if you think about it, if all the ice sank, the water levels would rise every winter and every lake would flood. The lake would flood. And so, but for things that live in the water, this is a super important property with, obviously. The other part of this is that on Earth, water exists naturally in all 3 states. It exists as a solid, as a liquid, and as a gas. You can find ice on Earth, you can find liquid water on Earth, and you can find gaseous water on Earth. And that is probably, I'm not sure about this, but I'm pretty sure it's also the only molecule that can do that. Okay, most molecules, like carbon dioxide, only exist naturally as a gas. Oxygen only exists naturally as a gas. The element gold only exists naturally as a solid on Earth. Property of water number 2. Water takes a long time and is slow to heat up or cool down. We say the term for that is a high heat capacity. You're not going to have to regurgitate high heat capacity, or it has a high specific heat. It takes a lot of energy to change states. It takes a lot of energy to change states. Because we are mostly water, this means that it takes us a long time to heat up or cool down. It would take a lot of energy input to heat us up. Okay, you understand this concept of water is slow to heat up or cool. Whoops. Water is slow to heat up or cool down. If you've ever heated water in a pan, you put the pan on the stove, and the pan gets really hot, and the water doesn't get very hot very fast. Okay, because water is slow to heat up or cool down. Has what we call a high specific heat. property of water number 3. And these all kind of go together. So I'm going to put them all up here and then talk about it. Not sure why the cat. The cohesion. That water sticks to itself. And adhesion, that water sticks to other surfaces. Now, if you think about this for a minute, if you take a shower, that's why the shower curtain, I'm guessing. I'm not sure why the cat. The water coming out of the shower head comes out in these little streams. The water doesn't all fall apart. The water doesn't spray all over the place. It sticks to itself. So you get water coming out of your hose in a stream. You're like, well, you've always seen that. You don't really think about that as being important for water, but that's what happens. But water also sticks to other things. It sticks to you. That's why you have to dry off. You have to scrub yourself with a towel to get water to quit sticking to you and start sticking to the towel. In fact, the more fibers in the towel, the softer and the more fibrous it is, the better it dries. Because now water will stick to the towel more than you. Okay? So the fact that water sticks to other surfaces and water sticks to itself is really important to help move water in plants. And we're going to look at that later on this year. But, and because, as we'll see also, as we've already seen, the importance of plants to life on Earth, we'll also talk about how water moves in plants and cohesion and adhesion. Now we want to talk about why that happens. The reason water sticks to itself and sticks to other things is that water is polar. Water is polar. If we go back to our sketch of a water molecule, this is the oxygen atom. And maybe I should have drawn on a different color here, the two hydrogen atoms. I use a different color for this. Hydrogen atoms have one proton and one electron, but it's being shared. Oxygen has 8 protons and 8 electrons, 2 of which are being shared. That means that these other electrons are on this end of the water molecule. I drew them as negatives. And the protons are on that end of the water molecule, making water have a positive end and a negative end. Like a magnet, water is polar, has a positive end and a negative end. Because water is polar, it can dissolve stuff. It dissolves things. Its negative and positive ends draw because opposites attract. Can dissolve things. For example, if we put salt, NaCl, into water, it dissolves. Why does it dissolve? Well, sodium chloride is actually sodium ions, which are positively charged, plus chlorine ions, which are negatively charged. When you dump that into water, the negative end, that is attracted to the negative end of a water molecule. And that is attracted to the positive end of a water molecule, and it's pulled apart. So, just salt, but you use water to dissolve all kinds of stuff. We use water to dissolve dirt. You take a shower to clean yourself up. You're using water as a solvent. And the stuff that's being dissolved in is called the solute. We put Kool-Aid. Here's the Kool-Aid man. We dump Kool-Aid into water and it dissolves. Why? Because the water molecules are pulling it apart. Now, it doesn't exactly dissolve all the way. There's a little bit of difference there. But whatever, the Kool-Aid is the solute, water is the solvent. When you take a shower, dirt is the solute, water is the solvent. You put your clothes in the dishwasher, clothes in the washer, and hopefully on the dishwasher, that'd be pretty entertaining. And sometimes you catch all, or you put them in a tub to wash them, and you get the water gets all brown because all the dirt has been dissolved in the water. The other thing that makes water polar, because water is polar, it's positive and negative end. So if we have a water molecule here like this, has a negative and positive end, it sticks to another water molecule. The positive end of one water molecule sticks to the negative end of another water molecule, and that makes them stick together. Okay, along with that is the concept of acids. An acid is a substance that breaks up into hydrogen ions when dissolved in water. So you take something and dump it into water, and it is broken apart and releases a bunch of things called hydrogen ions. Hydrogen ions are very reactive because a hydrogen ion has a positive charge. That means it has one proton, 0 electrons. And it really wants to add electrons. So what they do is they pull electrons away from other compounds. So if you dump acid on your skin, if you dump a strong enough acid on your skin, you've heard this, it'll burn through it. It'll burn through your skin. What's happening is it's taking the electrons and pulling them off your skin. And since electrons are what hold things together, your skin would fall apart. We use something to measure acids and bases on a pH scale. On the pH scale, the measurement would be for acid is from 0 to 6.9. We're going to look at the pH scale in lab in more detail. The second substance that we're going to talk about is called a base. A base is a substance that releases hydroxide ions when dissolved in water. It's also very reactive in a different way than hydrogen ions. We would measure something as a base from 7.1 to 14 on the pH scale. 14 equals the most hydroxide ions you can have. So many of you, maybe in some other class or in elementary school, took acids and bases and put them together. When you do that, you get what's called a chemical reaction. We need to talk about chemical reactions because what's driving you is chemical reactions. In a chemical reaction, you always make a new substance. Okay, that's the kind of the definition of chemical reaction. A physical reaction or a physical change would be something like ice to water, solid water to liquid water, not a chemical reaction. Not a chemical reaction. Dissolving salt in water, not a chemical reaction. Sometimes a new substance being formed includes a change in color or odor or something like that. Some examples of chemical reactions. Burning. Burn a piece of paper. Chemical reaction. Combustion is a fancy name for burning. Photosynthesis, as we'll see at the end of the year, is a chemical reaction. Something rusting is a chemical reaction. And you can probably think of many more. Here's one. If we took hydrogen ions and put them together with chlorine ions, we get hydrochloric acid. That's a chemical reaction. This car running is producing exhaust. That's because a chemical reaction is going on under the hood. It's a chemical reaction going on there. We're burning gasoline. Chemical reactions are shown with a chemical equation. So here's a chemical reaction. If we take hydrochloric acid and put in a base, sodium hydroxide, we get out water and salt. Water and salt. These two things, These are the things that react together. We call them reactants. For some reason, this is very hard to remember, for students to remember. I'm not sure why. On this side of the arrow are the things that are produced. They are called the products of the reaction. So we have reactants and we have products. Arrow points to what is produced. These are the things that react together. These are the things that are produced.